Hi guys, welcome to the channel. So in this particular video, we are about to discuss a very important topic from this particular chapter, and that is index of hydrogen deficiency. So we can get information about an unknown compound if we have knowledge about its molecular formula. So we have some general formulas for getting the information. So first of all, we will talk about some general alkane or some general alkene or cycloalkane, or we can have some general alkyne. If we talk about their general formulas, so for alkane the general formula is CnH2n plus 2. For alkene or cycloalkane it is CnH2n, and for alkyne it is CnH2n minus 2. If we try to understand these general formulas with the help of examples, we are just going to do is we will take n value equals to 2 in each of these cases. So first we will take the case of any alkane. So we have general formula CnH2n plus 2. We will substitute n is equals to 2 and we will get C2H 2 into 2 plus 2. So the formula will be C2H6. This is the formula of an alkane. As you can see, this is the formula of ethane. Now we will move on to the second general formula, that is CnH2n. Here if we put n is equals to 2, we will get C2H2 into 2, that is C2H4. So if we try to complete the valencies, so we have to make double bond here. So this is ethene, or similar will be the case of cycloalkane. You can check that as well. After that we will move on to alkyne, that is CnH2n minus 2. So if we put n is equals to 2, so that will be C2H2 into 2 minus 2, and that will be C2H2. So if we have C2H2, then we need to have triple bond. So this is an alkyne, right? This is type of an alkyne, right? This is type of an alkyne. Now this was with the help of an example. Now if we look at these general formulas, what we are going to observe is when we move from here to here, right, from alkane to alkene or cycloalkane, there is a difference of 2 hydrogens, right? 2 hydrogens are less in this case as compared to this one. Similar is the case from here to here, right? Here also there is difference of 2 hydrogens. So each time a pi bond or a ring is introduced, what happens? 2 hydrogens are reduced. This is one thing which we have to understand from here, that each time if we are going to introduce some kind of pi bond or some kind of ring, we are going to minimize 2 hydrogens. We are going to take 2 hydrogens out of that formula, right? Also one more thing, if we are moving from alkane to alkyne, or you can say in simple words, for every triple bond 4 hydrogens will be reduced. You can write down these things, that if we are moving from alkane to alkene or cycloalkane, or if we are moving from alkane or cycloalkene to alkyne, we have to reduce 2 hydrogens. And if we are moving from alkane to alkyne, then we have to reduce 4 hydrogens. Now we are going to understand this fact, how this works in terms of example. Now suppose we take the first example. We are having alkane, similar alkane which we discussed in the example, right? This is an alkane, and we are going to take out two hydrogens. Suppose these two hydrogens we are about to take out. Then what happens? If we are taking out two hydrogens, we can add one double bond. So what happens? We get alkene. So if we want to have alkene, we need to remove these two hydrogens, and from alkane we will get alkene. Now we will take a second example. Suppose we want to move from alkane to alkyne. So suppose we are having same alkane and we want to get alkyne. So we already discussed that we need to take out 4 hydrogens for that. So suppose we are taking these 4 hydrogens out. So after taking 4 hydrogens, we can introduce these triple bonds, and these 2 hydrogens will be here, and we will get alkyne. Now one more case of ring. We will take a case of a ring. So suppose we are having some sort of an alkane this is an alkane right now, right? This is an alkane. Now we want to take out 2 hydrogens. If we want to take out these 2 hydrogens, then what we can do, if we have taken out these 2 hydrogens, then simply we can change this into cycloalkane like this, right? If these 2 hydrogens are removed, then bond between these two will be formed and we will get a cycloalkane. So when molecular formula contains carbons and hydrogens, that is if we are having any organic compound, if we could take 2 hydrogens from alkane, we can get alkene. If we could take 4 hydrogens from alkane, we can get alkyne. If we are going to take out 2 hydrogens like this from the alkane, we can get a cycloalkane. But this was very easy till now. But when molecular formula contains non-carbon and non-hydrogen elements, then ratio of carbon to hydrogen changes, which we were discussing earlier in the general formulas. Then how we are going to predict the molecular formula? Suppose if the molecular formula contains any other elements, some other elements along with carbon and hydrogen, then the general formula for that will not remain as such, as we have discussed in this case, right? These were the general formulas, but not only carbon and hydrogen, some other elements are also present. Then what we are going to do? So for that, how we are going to predict the molecular formula? For that also we have 3 simple rules, right? But that we will discuss in the next video. What are those 3 simple rules? If we want to attach some other elements, then what all changes we have to make in these general formulas, that we will discuss in the next video. And after that we will do the unsaturation index, or what we say it as index of hydrogen deficiency. After that there is one rule, that is rule of 13. After that the chapter will be over. So I hope till now everything is clear, right? How we are going to get from alkane to alkene, or alkane to cycloalkane, or alkane to alkyne, how we are going to get, that is all clear to you guys. So I hope this video was helpful for you. So far that's it for this video. Thank you so much for watching.